Hello and welcome to a short video series on organic chemistry polymerization for the CAIE 0620 syllabus. This is meant to cover polymerization, addition polymerization in particular for this video, so let's get into it. This will be mainly based around the 0620 syllabus or the 0971 syllabus, depending if you're doing A to G grade scale or the 9 to 1 grading scale. Now, this should be really similar to the requirements for O-Level and Pearson, but always check against your syllabus. One more thing is that addition polymerization is a subtopic of polymerization, which is a subtopic of organic chemistry, so you should already have some knowledge of organic chemistry to understand what is going on in these reactions. So, let's get into it. How does polymerization work? Polymerization is the process of making polymers. Polymers are basically just long molecules. Usually, in chemistry, we deal with small molecules, and polymerization is the process of not making small molecules in normal reactions, but making large, extremely long molecules. These are made up of smaller molecules, which we call monomers. We are much more familiar with these smaller molecules. We take these smaller molecules and join them together to form a long chain, and this will form our polymers, which is our long chain. Now, there are many different types of polymers, and I'm sure that you're already familiar with some of them, one of which is plastic, nylon ropes. Nylon is a polymer, and it is used in ropes and clothing. We've probably seen already nylon ropes, which are used to hang clothes, and in clothing itself, for that elastic artificial feel you might get from clothing that isn't made of cotton, often uses nylon. Proteins. These are naturally forming polymers. They form from amino acid monomers. So the amino acids are the smaller units that join together to form a long chain, which is the final product, which is our protein. You probably know from biology that you take different arrangements of amino acids in different orders, and you join them together to get different proteins. So that's how polymerization is how we get to these final products. Polymerization does have a reputation, so this is always one step forward. Now let's actually get into addition polymerization and introduce the idea of both different types of them. There are two types of polymerization that we should be familiar with, and they are there because there are different types of polymers. We've seen in the previous slide. We have so many different types of polymers, and there are different ways to make them. So, what exactly is addition polymerization? Addition polymerization is where you take multiple monomers and you join them together to form a polymer. And it's an addition reaction. An addition reaction, you might be familiar from organic chemistry previously, is that multiple reactants are usually combined to form a single product. This long single product is our polymer. So you literally just take the monomers, our building blocks of this polymer, and you join them up together to form a long chain, which is our final product, of which we have only one. For addition polymerization, we use alkene monomers, and these combine to form long carbon chains, which of course are addition polymers. Now, we also have condensation polymerization, which we'll be going into in another video, hopefully, is that the majority of polymers we deal with are condensation polymers. This is something we should be familiar with. Actually, all the polymers I listed previously, proteins, plastics, nylon, are condensation polymers. We call them condensation polymers because other products are formed, and these products can often be gaseous due to the high temperatures polymerization occurs at. So there are other products that form other than the polymer, often water, but they can be other things. So now let's actually go into what addition polymerization is. Addition polymerization, as I mentioned, uses alkene monomers. And you may be wondering, polymerization is the process of joining multiple monomers together. But we already know that these ethene and propene already have all their bonds taken and they don't have any free bonds to attach to another monomer. So to attach another monomer, they would need to gain a free bond. And do you have any idea how could either of these alkenes possibly gain a free bond to join to another? If you guessed it, we lose a double bond. We break it open. If we don't have this double bond, just imagine we lose it. Each carbon would be connected to only 3 other atoms with 3 other bonds. And since carbon needs 4 bonds to have a full outer shell, it would have a free bond that could possibly connect to another monomer. The same process occurs here. This would gain another free bond, this would gain another free bond. So now let's actually see how that process actually works. So it opens its double bond, engages 2 new bonds, like this. So looking at ethene specifically, we see that ethene loses its double bond here, and we have only 3 bonds left. And since carbon needs 4 bonds, we represent it like this, with 2 free bonds just reaching out to join other ethene monomers that have also undergone this process of having their double bond open. Now this happens to obviously a lot of monomers, and all these monomers turn into this form of ethene lose a double bond, turn into this, and they just join together to form a long chain of ethene monomers, which is our polymer. And let's check out how this process works out for propene and butene and other alkenes, because this process occurs with small alkene monomers to form a large final polymer. So, as like with ethene, propene needs to have its double bond open, because that's the first step. And we open its double bond like this. It would lose this double bond. Let's see, this is what propene looks like. 3 carbons with a double bond on one here. We have lost a double bond, making it free, and this now only has 3, and this carbon also only has 3. So this guy would gain a free bond, and this guy would also gain a free bond. Forgive my anthropomorphization of organic compounds. Then we go here, and we see that this propene monomer has its double bond open, as we have drawn out here. It's the same thing. But you might notice that it's kind of awkward to draw because the free bonds are coming out at awkward angles. So you might have to draw the next propene monomer like this, the next propene monomer like this, the next propene monomer like this. So forgive me, let's go back. And it'll be really extremely weird for us to draw, and it might not be the most convenient option. So we just move this thing down. We just literally take this thing and move it out of the way, down, and we move this bond up here. It doesn't change the arrangement, it just changes how we view the atom, the monomer, and this is what we get after doing the switcheroo. We get this, which we call a repeating unit. A repeating unit is because this is what actually repeats in the polymer. We take this once, twice, thrice, while this, ignoring all the bonds, is propene. Ignoring all these drawings, this is actually what propene looks like. This is our monomer, but it's not a repeating unit, because a repeating unit has its free bonds and its double bond already opened. This is what it looks like in the monomer, in the polymer. And the propene isn't directly just dumped in a polymer. It needs this to happen to it first. Now this is how we represent the actual polymer. We put the repeating unit in brackets, and we put an n at the end. This n suggests that the repeating unit is repeated n number of times, which could be any large number, to form our actual polymer. Now you've probably seen this, but let's get into naming addition polymers, and we see here that this is called polypropene. Propene being our monomer, we just name it by adding poly to the name of the monomer. We already saw ethene getting polymerized in the previous slide, so that would be polyethene, because poly meaning multiple and the monomer is ethene. Here is just a representation of polypropene drawn out with its repeating units actually repeating. So here we have a 1 repeating unit, 2 repeating unit, 3 repeating units, 4 repeating units, 5 repeating units. Now we can't have all 3 carbons in a straight chain because this fellow does not have any free bonds that it could bond to another repeating unit. Only these 2 carbons that had the double bond before now have a free bond. This carbon here is unaffected and will not be able to bond, so it needs to stay out of the way here. This is not like with ethene. Ethene had just 2 carbons and both of them got free bonds, so it doesn't have any carbon alkyl sticking out from the sides. This is CH3, I've just compressed it in this notation because exams often use this notation as well. Let's actually move on into checking out how polymerization works for butene, and you can try it yourself because it's the exact same process as it is for other alkenes. Pause the video and try it out yourself. Okay, so we can get into doing the monomer. The monomer is basically just butene. Butene is an alkene with 4 carbons, and it's an alkene, so that means it's a double bond, and 2 means it's a double bond on the second carbon. 1, 2. This is how we draw it out. Now, how do we convert this to a repeating unit? To get the free bonds to attach to other monomers and to form our final long polymer, we would need to lose the double bond, so it gets free bonds, and this is how it would work. We get a free bond here, we get a free bond here, like this, and like this. And we do the switcher where we move this out the way down here and this out the way down here. No note that it would look different if it was just but1ene, which in that case we would have the double bond here and the carbons would have both of these 2 carbons on just hanging from 1 carbon, but that's not how it works here. That's not what actually happens in this case because the double bond is in the middle. So here we move the alkyls down the sides, and we can actually check how the polymer is drawn out. You can also try naming what polymer would form from this. Hazard a guess. So this is literally just the repeat unit put in brackets and with an N at the bottom. This notation is extremely important because it says the repeating unit is repeating. Here it says unit, that means it's occurring only once. So the brackets and the N is not necessary. Yeah, polybutene if you had guessed. Let's do a couple of topicals regarding addition polymerization. Actual questions from a past paper. Okay, pause the video and try it out yourself. Here we see that 200 molecules of ethene react to form a single molecule of X. Multiple molecules forming one giant molecule. That's going to be, so we know giant because it's 2,000 ethenes long. We know it's going to be pretty long and a pretty huge molecule. So we can assume that this is going to be a polymer and that this process is polymerization. So here we can see that this is going to be our monomer, small, and this is going to be our polymer, which is our large molecule. From our reaction, we could just easily assume that this is going to be an addition reaction because it's using ethene as a monomer. But just as easily, without even knowing about polymerization, we can know the same thing because it's multiple monomers, multiple reactants forming a single product. That made our answer A, by the way. Now let's go in the second question, pause and try it for yourself. The diagram shows part of a polymer. Which diagram shows the monomer from which this polymer is made? So here we have methane, and here we have ethane, and here we have ethene, and here we have ethanol. They all have 2 carbons, except methane, of course. Now, from which of these could this polymer be made? We know that it can be either methane or ethane because they don't have a double bond to lose and get a free bond from, so this would go out and this would be out. This has no double bond it has no double bond to open, and as well it doesn't have an oxygen on this thing, so it can't be this monomer. From here, this is a repeating unit of ethene. This is what it looks like if you open the double bond and draw out the free bonds. And as you can see here, that is actually repeating This is one repeat unit, this is one repeat unit, and this is one repeat unit. This can't be a repeat unit because obviously we don't have a methene alkene. That doesn't work out because there's no double bond to open, so that won't be working out as a possible monomer or a possible alkene at all. The answer for this is C, and this is actually getting to the end of the video. Okay, hello and thanks for getting for me to the end of the video. And this is it when it comes to polymers. This is not it when it comes to polymers. This is it when it comes to addition polymers, my bad. Condensation polymers are yet to be covered. Check in the description for more resources. I've added a couple more topical questions regarding addition polymers, so you can check that out. And good luck, have a great day.